To understand the oxidation of alcohol reactions, first you must be able to identify what type of alcohol you are working with. In order to do this, we have to look at it and assess what is present at the carbon that the alcohol is attached to, or the OH group is attached to. So we have different cases in front of us right now, and so I'm going to start with the first one. In this molecule, we're going to go ahead and look and see how many hydrogens are attached to this carbon. So this carbon that we have drawn hydrogens on, the reason I'm working on it is because it is the one that is directly attached to the OH group. And so we're able to identify that there is 2 hydrogens attached at this carbon. And in this type of scenario, the type of alcohol we're working with, we call it a primary alcohol. If you look at the notes, primary alcohol, you can do oxidation of them twice. And so after you identify the type of alcohol you have, you must now look at the reagent that you are working with. So the reagent typically will always be present where the arrow is in the reaction. And so in this case, PCCCH2Cl2 is a milder oxidizer or oxidation agent for these reactions. And so since it's a milder version of our reactions, or milder of the two, in this case we're only going to oxidize once. Okay, and so when you do that, you end up forming an aldehyde where the alcohol was attached previously. So here we have drawn in the aldehyde. You cannot do a second amount of PCC to go further into the carboxylic acid in this situation. If you wanted to form the carboxylic acid in a primary alcohol, you must use chromic acid. In the second one of the reactions I'm presenting, here again we want to identify what type of alcohol we are working with. So we must look at the carbon that has the OH attached, and here we can see that there should be another hydrogen attached here. So if there is only one hydrogen attached at that carbon, it's called a secondary carbon. Secondary carbons only have one hydrogen, and so that makes them only able to do an oxidation once. So it doesn't matter what type of reagent you're using, whether chromic acid or the PCC, you will get the same answer for both reagents. And that answer will be a ketone. Okay, so it doesn't matter whether you use chromic acid or PCC in those situations. If it's secondary and it's oxidizing, you will always make a ketone. The last example that I have here is going to be a tertiary alcohol. If we look at the carbon that has the OH attachment, you can see that it's already got 4 bonds to other carbons or other attachments, and so there's no hydrogens present. To do an oxidation of an alcohol, you must have a hydrogen present at these carbons. And since there is no hydrogen present, the reaction, no matter what reagent you're using for the oxidation, whether it's chromic acid or PCC, you will get a no reaction result.